So block on block. So write down block on block. Two blocks. Two blocks kept over each other. Two blocks kept over each other. And on smooth surface. Smooth horizontal surface. Note down block on block. So horizontal surface is there. This is the horizontal surface. What type of surface? Smooth or rough? Smooth surface. Now over it one block is there. Mass of this block is m1. Over it another block is there. Mass of this block is m2. Okay. This surface is smooth, frictionless, but this is rough. The surface between m2 and m1, it is rough. If it is rough, so coefficient of static friction mu s, coefficient of kinetic friction mu k. Okay, clear? So this is the arrangement. If one block is there, you know, suppose one block is there and this is rough, or suppose it is smooth. Let's do smooth. If it is a smooth, frictionless, so any force you exert, what is the acceleration? F by m. Okay. So very small force also, a small force also, block will move. Is there any stopping force? Any friction force? No. Suppose this is 2 kg and force is 0.1 Newton. So you can find acceleration 0.1 by 2. Correct? Force is very small, acceleration will be there because it is frictionless. It is frictionless. Correct? So now M1, M2. Now two blocks are there. In between rough surface is there. If you exert force on M1 and there is no slipping, so how to find acceleration? If no slipping, no slip between blocks, between blocks, so no sliding, no sliding. Okay, no sliding means this. Give me that wood. So one block is there. This is the surface. This is the surface. One block, second block, M1, M2. So I am exerting force on M1. Okay. So M2 is also moving. See, M2 is also moving. Correct. So common acceleration. So what is the common acceleration? Common acceleration. No slipping, no sliding. So these two blocks are like single block. Single block, what is the acceleration? F by m. Now you consider this as a single block. So what is the acceleration? Common acceleration. Common acceleration AC. Tell me. F by m1 plus m2. Okay. So note down. Common acceleration means no slipping. Blocks move together. Blocks move like a single block, like a single block. Two blocks, two blocks move, two blocks move like a single block. So total mass m1 plus m2. Like for example, you have 3 kg here, 3 kg, this is 1 kg, and you are exerting 10 Newton. And there is no slipping, no slipping, no sliding, no sliding between blocks, no sliding between blocks, and this is smooth. This horizontal surface is smooth. So what is the common acceleration? Tell me. 10 by 4. 10 by 4 means 2.5. Okay, clear? 2.5. Now, how to check no slipping is there? How to check? So now we are going to discuss. Okay, so note down. So case 1, note down. Force X on lower block. Force X on lower block. Note down. Force X on lower block. Lower block, what is the mass? M1. Upper block, what is the mass? M2. So draw free body diagram of both M1, M2. This is F. So M1, what is the free body diagram? M1, M1, mg downward, M1g, surface will exert one normal force, surface exert one normal force, upward, let's call it N1. What is N1? Normal due to surface. M2 will exert one normal force, downward. This is N2. So this N2 is from M2. This N1 is from surface. M1 is from surface. So what is the relation? They are balanced. M1 is not going up and down. M1 is sliding right only. So this is balanced. This is balanced. What do you write? N1 is equal to N2 plus M1. N1 is equal to N2 plus N1. Okay, clear? Balanced. Forces are balanced. Okay, understood? So vertical forces. And for M2, tell me what is the upward force? What is the upward force for M2? Normal from M1. So that is N2. This is N2. These are action reaction. This is clear. And what is downward force? M2G. So what is N2? Balance. N2 is M2G. Now put it here. So N1 is M2G plus M1G. Okay, clear? So this we have discussed before also. Points. You remember points? Coin quotient we have discussed. How much is weight above? Weight above is equal to normal. Like suppose 1, 2, 3, 4, 5, 6. So what is the normal here? 6 mg. What is the normal here? 5 mg. Here 4 mg, 3 mg, 2 mg. What is normal here? Mg. Here normal? 0. So this we have discussed. Now horizontal you have to think. Horizontal is important. So tell me, So what is horizontal force on M1 right side? F. This F is acting on M1. Okay, force acts on lower block. This is known as external force. This is known as external force. Now you see, with respect to M2, M2 is going right side. So M2 will exert friction on M1 left side. Are you getting? This force is acting on M1, correct? Force is not acting on M2, it is acting on M1. So with respect to M2, M1 is going where? Right side with respect to M2. So M2 will exert friction left side. So that is a small f. Now action reaction. M2 exert friction on M1 left side. So M1 exert friction on M2 right side. So for M2, friction will be right side. Note down. So friction will be right side. So draw this free body diagram. So this is M1, force is acting capital F on M1, with M2 will exert friction on M1 left. So M1 will exert friction on M2 right. So this free body diagram is clear. So how to write unbalanced force? Now what is the unbalanced force on M1? What is the unbalanced force? So F minus a small f is equal to M1 A. For this, what you write? Unbalanced force F is equal to M2 A. And common acceleration, you know what is the formula for common acceleration? F by M1 plus M2, correct? So see, common acceleration depends on F. If F is more, common acceleration is more. Like for example, this is 3 kg, this is 2 kg, and this is 10 Newton. So what is the common acceleration? 2. If this is 12, if this is 12 Newton, so what is the common acceleration? 2.4. 2.4. If this is 20 Newton, so what is the common acceleration? 4. So common acceleration is directly proportional to F. More F means more common acceleration. Now more common acceleration means more friction. But friction has limit. What is that limit? Tell me. Limiting friction, what is that? More acceleration means more friction. But friction has limit. What is the limit? Tell me. Maximum friction, how much? Mu s n. Mu s n1 or n2? The normal between blocks. What is normal between blocks? N2. Okay. So friction has limit mu s n2. And what is n2 value? m2g. So this is mu m2 mu s m2g. Okay, clear? So what is the maximum value of friction? Mu s m2g. Okay, clear? Maximum value of friction is mu s m2g. Suppose I am giving mu s 0.6. Mu s is 0.6. So what is the maximum friction? Tell me here. What is the maximum friction? What is the value of maximum friction here? Mu s m2g, m2. How much? 12. Okay, clear? So maximum friction is mu s m2g, understood? And this is common acceleration. So common acceleration into m2 is equal to friction. Now more common acceleration, when acceleration is more, when f is more. F more means acceleration more. Acceleration more means friction more. But friction has limit. What is the limit? Mu s m2g. So note down. So maximum common acceleration we can find. So F max is equal to m2 a max. M2 a max. So F max you substitute here. So mu s m2g is equal to m2 into a max. So m2 m2 cancel. So what is the value of a max? Mu s g. Mu s g. Note down. So this is maximum common acceleration. So this is known as maximum common acceleration. Okay. This is known as maximum common acceleration. Mu s g. Now come back to this formula. What is the formula for common acceleration? F by m1 plus m2. And maximum value of this we got. Now put it here. So right here. A max is equal to F max. Capital F, okay? Capital F means external force. Small f means friction force. So A max is equal to F max by m1 plus m2. Okay, capital F. So what is F max? What is the formula for F max? m1 plus m2 into A max. And what is A max? Mu s g. So what is F max? Mu s g into this. Understood? So m1 plus m2 mu s g. So this is the formula. Note down. Mu s m1 plus m2 into g. Very important formula. In your formula diary also you write acceleration, maximum acceleration mu s g, maximum external force, maximum external force, so that no sliding. Blocks do not slide. They will go together. Blocks go together as a single block. Blocks go together. Blocks go together as single block. Okay. Blocks go together as single block. How many blocks here? 2 blocks. So what is the common acceleration? Force upon m1 plus m2. Maximum acceleration is F max by m1 plus m2. So F max is m1 plus m2 into A max, and A max is mu s g. So this is the formula. Okay, clear? So how to check? How to check blocks go together or they will slip? Slip means like this. They go together or they slip. Now you tell me this, they go together or not? They are going together? Yes. Now I will pull it more force. It will slip. See, slip. It will slip. See, it will be go ahead. Like this. Okay, understood? See, slip. So it is slipping like this. So what is the What is the condition that they go together? Condition that blocks go together. What is the condition that blocks go together? F must be less than or equal to capital F. Capital F must be less than or equal to this mu s into m1 plus m2 into g. Note down. F must be this less than or equal to this. What is the condition that blocks slip? Condition that blocks slip. Block slip, what is the condition? F is greater than, very good. F is greater than mu s m1 plus m2 into g. Okay, clear? So just remember, memorize F is greater than mu s m1 plus m2g. So they will slip. Less than or equal to this, no slip. They go together. Okay, so no slip. Now I will give question, you tell me they will slip or not. Five kg, 4 kg, mu s is given 0.3, force acting 10 Newton. They will go together or they will slip. This is smooth. Tell if blocks go together or slip. They will go together. Okay, so first you calculate mu s m1 plus m2 into g. Calculate this. Calculate 0.3 into m1 plus m2 into 10. So 0.3 into 9 into 10. What is the answer? 27. And you are exerting 10. So 10 is less than 27. So no slip. No slip means they go together. They go together. 10 is less than 27. So they go together. Correct? Okay? They to go together. So common acceleration you can find. So what is the common acceleration? 10 by 9. 10 by 9 meter per second square. Note down. Common acceleration 10 by 9 meter per second square. Okay, next question. This is 6 kg, this is 4 kg. Mu s is 0.7. And I am exerting 10 Newton. They will go together or they slip. They go together or they slip. They go together. Correct. Okay, I will change this value. 100 Newton. Now they will slip. Correct. So mu s m1 plus m2 g, value of this is 0.7 into 6 plus 4 into 10 So 0.7 into 10, 7 into this 10, okay, 70. So I am exerting 100 Newton. So 100 is greater than 70. So slip, they will slip. They slip, so no common acceleration. They slip means no common acceleration. No common acceleration. Okay, understood? Are you getting? No common acceleration. They will slip. So they slip, okay? Because mu s m1 plus m2g is less and force is more. So they slip. Now go back to formula. So what is the value of friction? Find out friction. If they are going together, if they are going together, what is the value of friction? Yeah, this friction. So if common acceleration is there, so what is the friction? M2 into A. So this is the friction. Remember, this is the friction. M2 into A. What type of friction is there? It is a static or kinetic? The friction is a static or kinetic? Tell me. If no slip, it is static. Note down that also. If common acceleration is there, friction is a static. This is static friction. No slip. No slip between blocks. Okay, it is a static. Okay, new next page. So suppose this is M1, this is M2. You are exerting force F. You are exerting force F. This is smooth. This is smooth. Now here it is rough. This is mu S, mu K. Okay, and F is greater than mu S M1 plus M2 into G. So blocks will slip. Blocks will slip. So which has more acceleration? M1 or M2? M1. M2 will have less acceleration. M1 will go right side. Okay. So acceleration of 1 will be greater than acceleration of 2. And blocks will slip. So slip means sliding. So friction is static or kinetic? Friction, static or kinetic? Slip. Kinetic. Friction is kinetic. Note down. Friction is kinetic. So for M1, what you draw? For M1, right side capital F, left side mu K N2, mu K N2, and N2 value is M2G. N2 value is M2G. So this is mu K M2G. Understood? So what is the acceleration for M1? What is the acceleration for M1? Unbalanced force. What is unbalanced force? F minus mu K M2G is equal to M1 A1. How much is kinetic friction? Mu k n. What is n here? M2G. So what is the kinetic friction here? Mu k M2G. So for M1 friction is left, for M2 friction is right. Okay, you know these things. So for M2 friction is right, for M1 friction is left. Okay, so this is how you find A1, correct? Now M2. Now M2. What is the force right side? What is the force right side? M2. Friction. Force is right side. And it is kinetic friction. So what is the value of kinetic friction? Mu k N2. So mu k M2 G. Now this is the unbalanced force. So what you write? Mu k M2G, mu k M2G is equal to M2A2. M2 cancel. So what is A2? Mu k G. Note down. So you will get A1 using this, okay, and A2 is this. If force is greater than this, so blocks will slip. So different acceleration. Block slipping means different acceleration. Acceleration not same. Different acceleration. Which block has more acceleration? Upper block or lower block? Lower block. Very good. Lower block has more acceleration than upper block. A1 is greater than A2. How to find A1? Use this. How to find A2? Use this. Okay. So F mu k M2G. Okay. So now solve this question. This is 3 kg, 2 kg. This is frictionless. This is rough. Mu s is 0.2, mu k is 0.1. Now I am exerting 15 Newton. 15 Newton. Find accelerations of blocks. Find accelerations of blocks. So first you check they are slipping or not. Check they are slipping or not. Check slipping or not. What is F max? What is F max? Capital F max. Formula. Mu s M1 plus M2 G. Okay, calculate how much. Mu s 0.2. M1 means lower block, M2 means upper block. Slips, correct, good. So F max is 10 and you are exerting 15. External force is 15, which is less than, which is more than F max, which is more than F max. So block slip. So block slip. Blocks slip. So how to solve for 3 kg? 3 kg, what is the rightward force? 15. What is the leftward force? Mu k n. What is n here? N 20. So 0.1 into 20. 0.1 into 20. 2. So 15 minus 2. What you write? 15 minus 2 is equal to MA. So 3A1. So 13 is equal to 3A1. So A1 is equal to 13 by 3. A1 is equal to 13 by 3. A1 is 13 by 3. Okay, understood? And what is the acceleration of second block? So second block is mu kg. So 0.1 into 10. So 1 meter per second square. And acceleration of acceleration of 3 kg is 13.3. Okay, 4.33. 4.33. Yes. Okay. Okay. So first of all, what is the first step? What is the first step? Slip or not? So what is Fmax? Okay, mu s m1 plus m2 g. What is the Fmax value? 10. What force you are exerting? 15. So blocks slip. So friction is kinetic or static? Kinetic. So for 3 kg, 2 kg will exert kinetic friction. Okay. So 2 kg exert kinetic friction left side. And 3 kg will exert friction on 2 kg right side. So for 3 kg, right side force is 15, left side force is kinetic friction mu k, and so 0.1 into 20, 0.1 into 20. Okay, clear? So 15 minus 2 is equal to MA. M is 3. So 13 is equal to 3A. So A1 is 4.33. 13 by 3 means 4.33. Now 2 kg. What is the rightward force for 2 kg? Mu kn. Mu kn means 0.1 into mg 2. Then this is the net force. So Ma. So 2 is equal to Ma. So what is A2? 1. And A2 you can memorize that formula also. Mu kg. Okay. Mu k g, like this. For upper block, mu k m2 g is equal to m2 a2, m2 m2 cancel. So a2 is equal to mu k g. Okay, are you getting? Okay, good. Okay, these topics are critical topics. Okay, you have to revise again and again. Now solve this question. Block on block. So T mu s is given 0.7, mu k is given 0.4. This is rough. This surface is rough. This surface is smooth. So now force value I will give 30. Find friction force between blocks. Find value of friction force between blocks. Find value of friction force between blocks. Now, what is your first step? Slip or not slip? Correct. Good. So, check slip or not. Check first. Check first, slip or not slip? Not slip. Correct. Good. So, acceleration is common. So, what is the formula for common acceleration? Correct. Good. So, find out. 6. Correct. And what is the value of friction? Friction is friction is M2 A, correct? Friction is M2 A when no slip. Remember? Friction is M2 A. Friction is M2 A when no slip. When no slip. So how much friction? Tell me. And A value you got 6. A value is 6. M2 is 3. So 18. Friction is 18. 18 Newton. What is direction of friction on 3 kg? Right? Friction on 2 kg? Left. So on 2 kg, friction is 18 Newton left. On 3 kg, friction is 18 Newton right. Correct? Note down. Friction is 18 Newton right. So this is block on block. So it is case 1. Okay. So what is case 1? Force is acting on lower block and ground is smooth and blocks are rough. Blocks are rough. Okay, clear? Any problem? Okay. Okay, understand. Then revise. Keep revising. Afternoon, evening, morning, you read it again. Okay, you will understand. It is easy. So, let's see any question is there. So, laws of motion. Page 280, 71 question. Question 71. Solve. 33 also. Wait. Page 276. Page 276, question 33. Page 280, question 71. So, solve this first. Page 276, Question 33. Block 4 kg. 4 kg block A. This is B, this is A. This is F. What is the mass of B? Tell me what is mass of B? 8 kg. A 4 kg. A is 4 kg. A just slipped. Question is written. A just slips. A just slip when F is equal to 12. A just slip oh, this is case 2 mixed. Wait. Case 1 and case 2 mixed. I will come to case 2. Okay, solve question 71. This is case 1 and case 2 mixed. Or shall we? Okay, no problem. Let's do case 2 also. Then I will come back to this question. Write down case 2 also. It is easy only. We will finish in 5 minutes. We will finish. Note down case 2. This is M1. This is M2. Force is acting on M1. Note down. What is case 1? What is case 1? Force is acting on M1. What is case 2? Force is acting on M2. Upper block. External force acts on upper block. External force acts on upper block. So again same procedure, same method. If they are going together, if they go together, if they go together, what is the common acceleration? F by m1 plus m2. So common acceleration F by m1 plus m2. Now free body diagram for m2. Right side is F, downward is m2g, upward is n2. Now related to m1, with respect to m1, m2 is going right side. So friction from m1 will be left side. Good. So m1 exert friction on m2 left side. So for m1 friction will be right side. Good, very good. So for m1 what you write for m1? F is equal to m1 a1. And for m2 what you write? F minus F. F minus small f is equal to m2 a2. Note down. So if no slip, now you see when force is more, force you increase force, A also increase, AC increases. If F increases and if A is increasing, both A1 A2 same only. See A1 A2 both are same here. A1, A2 both are same. Write AA, okay? AA. Okay. So if A is more means F is more. A is more means F is more. Now what is maximum value of F? Tell me. F friction maximum value mu s N2. Good. So what is N2? M2G. Correct. So maximum friction is mu s M2G. So what is the maximum value of acceleration? Maximum value of acceleration. Now put F max this here. Mu s M2G is equal to M1 into A max. So what is A max? Mu s M2 by M1 G. Mu s M2 by M1 G. Okay, this is the formula. A max. So what is F max? Capital F max. Capital F max is equal to M1 plus M2 into A max, and A max is this mu s M2 by M1 into G. Okay, note down. So this is the formula for F max. Okay. So F max is equal to mu s M1 plus M2 M2 by M1 into G. Maximum common acceleration is mu s M2 by M1 G. Maximum external force mu s M1 plus M2 M2 by M1 into G. If force is more than this, then kinetic friction will act. If F is greater than F max, so they will slip. So they slip means kinetic friction will act. So for lower block, kinetic friction mu k M2G, and for upper block, right side capital F, left side mu k M2G. Are you getting? Come to the diagram, the free body diagram. Free body diagram of M1. What is the rightward force? Friction. So if they are slipping, so friction is kinetic. So what is the kinetic friction? Mu k M2G. And for M2, right side capital F, left side mu k M2G. Okay, clear? Now find accelerations. They slip. They slip means acceleration different or same? Different. So they have different acceleration. Different accelerations. So how to find acceleration of M1? Unbalanced force is equal to MA. Mu k M2G is equal to M1 A1. So what is A1? Mu k M2 by M1 into G. How to find acceleration of M2? F minus mu k M2G is equal to M2 A2. So you can find A2 F by M2 minus mu k G. Note down. These are the equations. So this is case 2. So case 2, force is acting on upper block, remember. Case 2, force is acting on upper block. Force is acting on upper block. So common acceleration, same formula, F by m1 plus m2. Common acceleration, so friction is m1a. Okay, for m1 friction is this F. What is the direction of friction on m2? Left. Friction on m1? Right side. So F is equal to m1a. So this is common acceleration. Acceleration common maximum value is this. When F is maximum, A is maximum. When A is maximum, friction is maximum. Maximum friction mu s m2g is m1 a max. Okay, clear? So maximum acceleration you got. So maximum force you got. Okay. So finish. So case 1, what is the maximum acceleration? Case 1. Case 1, what is the maximum acceleration? Mu s g. Case 2, what is the maximum acceleration? Mu s g into m2 by m1. Upper block by lower block. Upper block by, suppose upper block is 3 kg, lower block is 2 kg. So you will write mu s 3 by 2 into g. Okay, clear? And this is maximum force. If force is more than this, so different acceleration. Which has more acceleration, upper or lower? Force is acting on 3 kg. Which has more acceleration, 3 or 2 kg? 3 kg. 3 kg more acceleration. So you can write down this also. Upper block accelerate more. Upper block has more acceleration, greater, more acceleration or greater acceleration. Upper block has. In case 1, which has more acceleration? Case 1. Case 1, which has more acceleration? Lower block. Case 1, lower block has more acceleration. Now come to that question. So I am writing both formula again. Suppose force is acting on lower block. So A max is mu s g, F max is mu s m1 plus m2 g. If force is acting on upper block, so A max is mu s upper block by lower block mass g, F max mu s m1 plus m2 by m1 into g. Okay, clear? So remember this. Now come to that question, 76 page, 276. '33 question. What is given? 4 kg block A kept on 8 kg block. So this is 8 kg, this is 4 kg. A just slip on B. A just slip on B. If, what is the condition? If 12 Newton applied on A. 12 Newton applied on A. So means force is acting on A, upper block. Which case? Second case. Second case. So what is the formula for F mu s m1 plus m2 into, understood, m2 by m1 into 10. This value is given as 12. Okay, clear. Now what is the question? Then maximum horizontal force F applied on B. Maximum horizontal force applied on B. Now you find out this. Now lower block. So what is the formula? Maximum mu s m1 plus m2 g. Now what is mu s m1 plus m2 g? Calculate. This is mu s m1 plus m2. So mu s m1 plus m2. What is the into g? What is this? 4 by 2, 4 by 8, 1 by 2, 2 is here. So 24, correct? Are you getting or not? So 24, note down. $24. Okay. Now page 80. Question 80, page 281. Okay, this question clear? Any problem? Case 2. So mu s m2 by m1, m1 plus m2 g. This is given as 12, and they are asking mu s m1 plus m2 into g. So 12 m1 by m2. 12 m1 by m2. Now question 80, page 281. Lower block, what is the value? Mass 40 kg. Upper block 10 kg. Force is acting on lower block or upper block? Force acting on lower block or upper block? Upper block. How much force you are exerting? 100. So mu s is given 0.6. Mu s is 0.6. Mu k is given or not? 0.4. Mu k is 0.4. What is the question? Acceleration of slab. They are calling it as slab. This is slab. Okay. What is the acceleration of slab? What is the acceleration of slab? Tell me. Means first you check it is slip or not. Slip. Check. Check. Slip or not. Blocks slip or not. Check. What is the value of it? Is case 1 or case 2? Case 2. Case 2, what is the maximum force? Mu s m1 plus m2 m2 by m1 into g. Calculate. So mu s m1 plus m2. Which is m1? Which is m1? 40. So 40 plus 10 into m2 by m1. So 0.6 into 50 into 10 by 4, 30 into 10 by 4, 75. So maximum force is 75 and you are exerting 100. So they will slip or not slip? They will slip or not slip? Slip. So 75 and you are exerting 100. So 100 is more than 75. So blocks slip. So they have same acceleration or different acceleration? Different acceleration. Good. So what is the formula for lower block? Mu k. For lower block, what is the formula? Tell me. Mu k means A1. A1, what is the formula? A1. Mu k M2 by M1 G. And A2, you calculate using this. Okay, this is A2. So you can memorize easily upper block by lower block. Upper block by lower block into G. So this is A1. Acceleration of lower block. Acceleration of lower block. So now mu k 0.4 upper by lower. Upper by lower into G. 0.4 into 10, 4. This 10, 10 cancel. So 1 by 4. So 1. A1 is 1. Now what is A2? Upper block. F by, you can solve like this. F minus mu k M2G is equal to M2A2. Now F is 100 minus mu k M2G. Mu k M2G how much? 0.4 M2 is equal to M2A2. Solve this. So 100 minus 40 is equal to 10A2. So 60 is equal to 10A2. So A2 is equal to 6. Okay. A1 is equal to 1. Acceleration of lower block is 1. Acceleration of upper block is 6. So 0.98. Okay, note down. If you take G as 9.8, you will get 0.98. Correct? If you put 9.8 here, 9. Okay, understood? So 9.8 here you put, you will get 0.98 here. So which option? 1 meter per second square. Okay, fourth option, 0.98. Okay, now I am giving some more questions. You practice this. It is very important chapter. So solve these questions. If you have any doubt, you can ask. Find friction force between blocks. Find acceleration of blocks. Find acceleration of blocks. Okay, so solve what is the friction, what is the friction between blocks, and what is the acceleration of blocks. And then you can solve some more. Page 280, 76, 76, 74, 81. Okay, try these. Okay, solve. Take 10 minutes. Okay, solve. Okay, I will come back. Okay. So slip or no slip? Slip. Okay. So F max is equal to 0.3 into 1 by 2 into 3, correct, good, into 10, 9 by 2, so 4.5, and you are exerting 6, so slip. So accelerations are not same, A1 are not equal to A2. So friction will be kinetic, so friction will be mu k m2g. 0.2 into m2 into g. Friction is 2 Newton. What is direction of friction on 1 kg? Friction, left side, good. 2 kg, right side. Okay, now acceleration, let's find acceleration also. So slip. So for 1 kg, right side is 6, left side is friction, 6 minus 2 is equal to 4a, sorry 1a, 1a2. So a2 is equal to 4, right side. And for 2 kg, correct, force is 2, friction is 2, so 2 is equal to 2 into a1, a1 is 1, understood? Now question 2, slip or no slip? No slip. Okay, so this is case 1, so 0.3 into m1 plus m2 into 10, 3 into 3, 9, and you are exerting 6, so no slip. So acceleration is same, common, acceleration is common. So what is the formula for common acceleration? 6 by 2 plus 1, so 2 meter per second square. Acceleration is common. So friction formula, what is the friction formula? M1A or M2A? M2A, good. Friction is M2A. M2 is 1. Okay, friction is 2. This is case 1. Case 1. Okay. Question 2 is case 1. Question 1 is case 2. This is case 2. Now question 3. Question 3 is case 2. So what is F max? So first you tell me is a slip or not slip? Slip. Okay. So mu s m1 plus m2, m2 by m1 into g. (33 by 2), 16.5. and you are exiting 20, so slip. So 20 is greater than 16.5, so blocks slip. Blocks slip. So acceleration different. Accelerations are different. So for 3 kg, right side is 20 and left side is kinetic friction. Left side is kinetic friction, mu k n, mu k m2g, mu k 0.3, m2g. So 20 minus 9 is equal to ma. 20 minus 9 is equal to 3 into a2. So 11 by 3. 11 by 3 is equal to a2. Okay, 3.67. 3.67. Correct? 11 by 3, 3.67. Okay, good. Now this is for 3 kg. Now for 4 kg, this is question 3 only. Okay. Now for, sorry, yes, for 8 kg, correct, 8 kg. Right side is kinetic friction. So 9 is equal to 8 a1. So a1 is equal to 9 by 8. 1.1. a1 is equal to 1.1. Now come to question number 4. Question number 4, F max. It is case 1. Case 1, F max is mu s m1 plus m2 into g, 2 into 3, so 6. And you are exciting 9. 9 is greater than 6. So blocks slip. Good. So blocks slip, A1 and A2 not equal. A1 and A2 not equal. So for 1 kg, what you write? For 1 kg you write friction will be right side, mu k m2g. So 0.1 m2g. So 1. So 1 is equal to ma. 1 a2. So a2 is equal to 1. Correct? Now 2 kg. Right side is 9. Left side is mu k m2g. Okay, friction. This is friction. So 9 minus 8 is equal to m2, sorry, m1. m1 a1. Correct. m1 a1. 9 minus 1. Correct. 9 minus 9 minus 1 is equal to 1 into, sorry, 2 into a1. 2 into a1. 8 by 2 is equal to 4. A1 is 4. Okay, clear, understood. Friction is 1. Friction is 1. A2 is 1. A1 is 4. A1 is 4. Okay, now, so this 76, 74, 81. 76, 74, 81. Okay, try this question. Ah, 74. So it is looking very big question, but try to solve it. So how many blocks are there? This is the wall. This is the block. Two blocks. Correct. Good. So 25 kg and 15 kg. You are exerting force like this. One string is going over this pulley is there. Like this. Here clamp is there. Clamp. Okay. Coefficient of friction for all surface is a 0.4. Find minimum F to have equilibrium. Find minimum F. Find minimum F to be in equilibrium. Equilibrium means net force 0. Net force 0. So see, suppose you don't exert any force. You think like this. Suppose F is not there. What happens? If F is not there, what happens? 25 kg down, 15 kg up, because this is more mass. So 250 Newton here. Okay, so here 250 Newton. So here 125 Newton, 125 Newton, and here downward force is 150. So 25 kg will go down, 15 kg will go up. So see, okay, this is 25 kg. So this is going down. So friction from wall, what is the friction? It will be upward. Here friction is upward, correct? Now relative to 15 kg, 25 kg is going down. So 15 kg will exert friction on 25 kg upwards. Correct, good. And friction on 15 kg due to 25 kg downwards. So first you understand this. So this is friction on 15 kg due to 25 kg, and this is friction on 25 kg due to 15 kg. This is friction on 25 kg due to wall. Friction on 25 kg due to wall. Okay, clear? Okay, fine. Now it is in equilibrium. So free body diagram you draw. So for 25 kg, what is the downward force? 250 mg. Okay, this is F1. We call it F1. This is F1. So this is also F1. Oh, sorry. No, wait. This is F1. This is F2. This is F2. These are action reaction, okay? So F1, F2, tension is there, here tension is there. Now balance it. So F1 plus F2 plus T is equal to 250. Now here T, so here T by 2, T by 2. So here T by 2. Now for 15 kg, this is T by 2, F2, 150, correct. 150. So balance it. So T by 2 is equal to 150 plus F2. So it is just in equilibrium. Now F, you are exerting F here. So what is the maximum value of F1 here? Maximum value of F1. See, normal here will be F. Normal here is also F, correct? So what is the maximum value of F1? Mu S into normal. And what is normal here? F. Now come to F2. F2 also same, mu S into normal. So 0.4 into F. So F1 and F2 both are equal. F1, F2 are equal. Now substitute here. So 0.4 F, 0.4 F, substitute. 0.4 F plus 0.4 F plus T is equal to 250. How much? 0.8 F plus T is equal to 250. Now T value you find. What is T value? Find from here. So T is equal to 300 plus 2F2. So 300 plus 2F2. F2 is this 0.4 F. So T is equal to 300 plus 0.8 F. Capital F, okay? 300 plus 0.8 capital F, tension. Now you put tension value here. So 0.8 F plus tension, which is 300 plus 0.8 F. 300 plus 0.8 F is equal to 250. Oh, F2 is that T by 2, 150 F2. F1, F2, 3, 2.4. You have to find F. Calculation you check once again. 0.4, 0.4, 0.8 F plus T is equal to 250. 0.8 F plus 300 is equal to T. It's coming negative. So that means this is going down, this is going up. Okay, let's solve. This is going down, this is going up. Now solve again. This is 25 kg, 15 kg, this is going up, this is going down, this is going up. So friction is here 0.4 F. So one more friction will be here due to this 0.4 F. Tension here T by 2. And for this friction will be up mu Sn. Now solve 0.4 F plus 0.4 F plus 250 is equal to T, correct? For this 150 is equal to 0.4 F plus T by 2. Now T by 2 is you multiply by 2. So T value is 300 minus 0.8 F. One 1.6 F is equal to 50. So F is equal to 50 by 1.6. 50 by 1.6 how much? 500 by 16 how much? Cancel by 25. 5 no, cancel by 4. Cancel by 4. 4 times 25 times. 25 into 5 125. 125 by 4 31.25. Oh, it is not there. 25 by 4. In the solution they have given like this. Yes. Tension is 2T. Okay, okay, okay. Actually they have solved wrongly. This 0.4 F, this 0.4 F is correct, but this is upward. Here they have taken opposite direction. That's wrong. Okay, solution is wrong. This is correct. So second case is correct. This case is correct. In this case, which is going up? $25 kg is going up. This is going down. So friction on 15 kg will be up and 25 kg will be down, and wall will exert downward friction. "25 kg tends to go up, 15 kg tends to go down, 15 kg tends to go down." This is correct. See, both these friction same direction, okay? Here they have written wrong, opposite direction they have written. Solution is wrong. Okay. Any more question? So this is correct. Note down. Okay, next question. Any more? Okay. Any more question? Okay, page 84, assertion reason is there. No, that is lower surface also rough. We'll discuss that later. Yeah, last question, 81. Okay, solve 81. Two blocks are there. Diagram is incomplete. Draw this diagram. There is a string here, string. Now this is rough surface. This is also rough surface. Now mu value is given. What is the mu value? Between A and B it is 0.2, and between ground and B, 0.3. Between these two, 0.3. Between these two, 0.2. Find minimum F to move B. To move B. Find minimum F to move B. Find minimum F to move B. So when you try to move B right side, friction will come from ground left side. You call it F1, and so first you have to overcome F1. First overcome F1. What is the maximum value of F1? Maximum value of F1. What is the normal here? Masses are given 100 and 200. A is 100 kg, this is 200 kg. Tell me what is the maximum value of F1? Mu s into total mass. How much? 90. So it will slip. It will slip over ground. Over ground it will slip. Now it has, now A will exert friction force. Yes, tell me. Where? In this question? In this question? Maximum F1. Yes, correct. Good. So 900, correct. So F1 is 900, correct. Good. F1 is 900. Now friction will come from here also. F2. Now overcome F2. Tell me what is the maximum value of F2? Mu s 1000, 200. So total is 1100. Okay, clear. And what is the tension? Tension here will be, what is the friction here? Same. So friction on A will be right side. Okay, action reaction, and tension will be equal to F2. So what is the tension value? Tension value is equal to F2. And what is F2 maximum value? 200. So tension is 200. Okay, friction is 200. So balance. Are you getting? B is going right side with respect to A. So A exert friction on B left side. So B exert friction on A right side. Okay, clear? Yes, tell me, what is your doubt? What is the answer? Correct, C option. Hmm. Now tell me which one? Huh? Okay. See, B, you are exerting force on B. So B is kept on ground. So ground will exert force, friction force left. So first you have to overcome F1. Now what is the normal here? Normal value. Total mass. What is total mass? 300. Correct. So maximum value of F1 will be mu s n. Now what is normal here? 300. So 300 G. So mu value, what is mu value? 0.3. So what is F1? 0.3 into 300 into 10. So this is 900. Okay, clear? So this is 900. Now B, over B there is A also. Are you getting? Like suppose this is the surface of A and B is like this. B is going like this. B going like this. Okay. So A will exert now, A will exert friction also on B. So what is that friction? Mu s n. Now n here, what is n? 100 G into mu s. Okay, understood? So 200. So F2 is 200. So B will overcome both F1, F2. Okay. So 200 and 900. So what is total? 1100. Okay. So minimum force, minimum value of F is 1100. Okay, fine. Now one more is there, 72, page 280, page 280, 72. Two blocks M to M placed one over other now this is a question. Force is acting on upper block. Now this is the string, okay, this is a string. Two blocks M to M placed one over other. The coefficient of friction between M to M is mu. Between M to M it is mu, and between 2M and the floor mu by 3. Mu by 3. What is a normal here? Tell me. What is a normal value here? What is a normal value here? Tell me. 3 mg. Good. What is the normal value here? Mg. Normal is mg. Here normal is mg. Here normal is 3 mg. If horizontal force F applied on upper block, T is the tension on the string. T is the tension on a string, correct? Choose the incorrect. So basically you have to find F and T value. And they are at rest, correct? They are at rest. Assume they are at rest. Okay, so for M, what is the direction of friction? Left. For 2M, what is the direction of friction due to M? Right side. Good. Now because of this friction, 2M will move right side. So ground will exert friction where? Left side. Okay, you can call it F1. So this is F1, this is F2. Are you getting? This is F1 on M due to 2M. Action reaction. So this is F1 on 2M due to M. So free body diagram you can draw like this. Capital F right side, F1 left side. Okay, normal N1 mg. And for 2M you can draw F1 right side, F2 left side, tension also left side, and 2 mg downward, and N1 downward, N1 also downward, N2 upward. This is N2. Okay, clear? Free body diagram. Now balance. So what is F1? F, and F2 plus T is equal to F1. Okay, one by one we have to go. One by one. What is the first option saying? What is the first option? Capital F is equal to mu mg by 3. Now what is the maximum friction here? Maximum F1, tell me what is maximum F1? Mu mg. So maximum friction is mu mg, and you are exerting mu mg by 3. So block will not move. Understood? Block will not move. So now you combine these two blocks. What is the combination? 3M. Now for this 3M, you are exerting this force. Now these are internal forces. These are internal. You are exerting this F mu mg by 3. Now what is the maximum F2? What is the maximum F2? mu by 3 into normal. Now maximum F2 is mu mg, and you are exerting only mu mg by 3. So 2m will not move. 2m will not move. Okay, because this whole, if you consider this whole object as one, what force you are exerting? Mu mg by 3, and maximum friction from ground, how much? Mu mg. So they will not move. So how much is F2? Tell me. F2 how much? Tell me. The whole 3m not moving. So what is F2? Mu mg by 3. Okay, understood? So F2 is mu mg by 3, and so the 2m is not moving right side because is more friction is more, so tension will be 0. Are you getting this point? Tension will be 0. See why tension is 0. See here. Suppose this is the block. This is the block 3 kg. This is the string. Suppose mu s is 0.4 and you are exerting 8 Newton. You are exerting 8 Newton. Tell me what is the tension? You tell me what is tension. First you tell what is the maximum friction. Tell me. Maximum friction. What is the maximum friction? Tell me. Mu s n mg. So 0.4, 30. So what is the maximum friction? 12. And how much you are exerting? 8. So the block will not move. So what is the friction right now? 8 Newton. Very good. So there is no need of string. Okay. So tension will be 0. So friction will be 8. Tension will be 0. What if you exert 15 Newton here? Suppose this is 3 kg and you are exerting 15 Newton. Now you tell me what is tension? 3 Newton. Correct. Good. So now friction will be maximum because you are exerting more force, more than 12. So friction will be maximum 12 and you are exerting 15. So remaining 3 Newton will be the tension. Okay. So tension is equal to 3. Are you getting? So same this concept in this also. So here if you combine this, if you combine this object, so m plus 2m, and you are exerting force F is equal to mu mg by 3. And what is the maximum friction here? Mu mg. And you are exerting mu mg by 3. So there is no tension here. Okay, so tension is 0. And what is F2? F2 is mu mg by 2. Oh, 3. Mu mg by 3. Balance. So mu mg by 3 plus 0 is equal to F1. So F1 is equal to mu mg by 3. Tension 0. So A option is correct. Okay, first option is correct. Now what is the second? Second is F is equal to mu mg. Now consider F is equal to mu mg. If F is equal to mu mg, and what is the maximum value of F2? Mu mg. So here maximum friction is mu mg and you are exerting mu mg. So this object will not move. So what is the tension? 0. So tension will be 0. Correct. Good. Now third, F is equal to 2 mu mg. F is equal to 2 mu mg. Now here 2 mu mg. If you see the one object, so here friction F2, now maximum value of F2 is mu mg and this is 2 mu mg. So friction is not sufficient. Friction is not sufficient. So tension will be there. Okay, tension is there. So what is the acceleration of 2m? Acceleration of 2m will be 0 because the string is there. So 2m acceleration 0. So friction on m will be left and friction on 2m will be right. So now you come to m. So for m, what is the maximum friction? F1. What is the maximum value F1? Tell me. Maximum value F1. Mu mg, correct. Mu mg, okay. And you are exacting 2 mu mg. So it will slide. So 2 mu mg minus mu mg is equal to ma. So acceleration you are getting. So mu mg is equal to ma. So a is equal to mu g. Okay, a is equal to mu g. Acceleration of m. Acceleration of m. What is acceleration of 2m? Acceleration of 2m is 0. So F1 value we got, F1 value is mu mg. So for 2m right side is mu mg, left side is tension, and F2 maximum value mu mg. So tension 0. Okay, right. Tension is 0. Now fourth, F is 3 mu mg. So so 3 mu mg minus mu mg is equal to ma. Two mu g is equal to a. Acceleration is 2 mu g. Now this is mu mg. This is mu mg, so this will be mu mg. Correct, because maximum value is mu mg only. So mu mg cancel. So tension 0. Okay, third option. Correct. Tension is 0 in all cases. So third is wrong. Correct. Third option is wrong. Okay, we'll continue then. Okay, fine.